Welcome dear student. Myself Mukudholkar, lecturer in Mechanical Engineering Department, Guru Gobind Singh Polytechnic, Nasik. So today we will learn the topic spring. After watching this video, you will be able to know the spring application in mechatronics system, then basics of spring and its types, and last one is troubleshooting of the spring. So first we will move to the application of spring other than mechatronics. So you can observe here there are variety number of applications: electronics and medical devices, aerospace, railroad, automotive manufacturing, machinery, and so on. So in each and every industry, almost all the industries are use spring for various purpose. As far as mechatronics is considered, so here is the application of spring in mechatronics system. In first figure, that is actuator application. So this is a typical single cylinder, single acting a pneumatic cylinder with spring loaded. So here you can use the spring for its return stroke. We will learn this pneumatic portion in next week. Then next one is wall control. So in walls also we are using the springs. So that's why the spring is included in mechanical compounds. Then fundamentals. So spring is an elastic object that stores mechanical energy. So there are many spring designs in everyday use. The term often refers to coil spring. So coil spring we are using in maximum times in industry, and all the terms are designed as per the coil spring. So spring are the part of elastic forming element, that is they reshape themselves under strain or release. So under strain, or you can say release, so they can reshape their again into its original position. So you can clearly observe in figure also. In first figure, so we are applying a mass of m, so its elongation is x. As you apply the mass to m, means you have double the mass of initial, so its elongation will be increases from x to 2x, like that. The energy required for reshaping is saved as potential energy and pass on again after release or spring back. When you remove the mass, so it will again moves to its original position. So when you apply the mass, by applying the mass, the spring get deflates and stores the potential energy. When you release the force or release the load or remove the load, so simply it moves to its original position. So this is the fundamental of spring. So it basically stores the mechanical energy, and that mechanical energy means potential energy. Then terminologies. So you can observe the figure. This is a typical coil spring. So one by one we will learn the concept. First one is wire diameter. So in case of coil spring, wire diameter is represented as you increase the wire diameter, so you are increasing the strength of the spring. Then pitch, distance between two consecutive wire diameter or coil. So this is known as a simple coil, one coil, two coil, and these coils combined together known as coil spring, helical coil spring, like that. They are having a shape of helical or helix shape is there, hence it is known as helical coil spring. Then this is a free length. So free length you can also call it as a original length, no force is applied, so this is a free length. Then inside diameter, and outside diameter. So you can clearly observe. Then in below figure you can see the pitch they are showing, then small d they are showing here. So pitch, then your diameter. So d is represented as wire diameter, pitch is for p for pitch, that is distance between two consecutive coils. And in next figure you can observe here you are applying the load W, so it gives you the deflection of delta. So delta is there. So this is a compressed length, and if you further apply the load, still you have increases the load. At some point it get connected and you can call it as a compressed solid. So after solid length it cannot compress, so you can also call it as a maximum compression. So free length, compressed length and compressed solid. So this is the terminology of your helical coil spring. Then we will move to the spring types. So springs are classified based on their shapes, and shapes are also decided according to their application. So each and every application requires a specific shape spring. So we will learn one by one. First one is helical spring, extension spring, torsion bar spring, flat spring, lip spring, torsion, and last one is rubber, or you can also call it as a shock absorber. So first one is coil spring. You can observe the coil spring in a picture. So before that, you already know the application of helical spring. You are using in various number of application. So your two-wheeler automobile rear shock absorber or back side shock absorber uses the helical spring. So why these springs are called as helical spring? Because helical springs are made of wire coiled in the form of helix. So it is having helix like structure, so hence it is called as helical spring. And their cross section, if you take a cross section of coil diameter, so generally they are circular, but as per your application they may be square or rectangular also. Helical coil spring are very easy to manufacture, reliable, and have a constant spring rate. So these are the some of the advantages of using the helical coil spring. Here the one term is the spring rate. So spring rate means spring deflection is directly proportional to the force acting. So deflection, that is delta, is directly proportional to W. So this is the simple logic. So that's why they use in most of the industries and various number of application. Then second one is extension spring. So they look like same as your helical coil spring, but they are initially in its original position, they are in solid length. So these type of springs are used in weighing machine. They already store the potential energy, and when you apply the load they are actually releasing the potential energy. So extension springs are designed to absorb and store energy as well as to create a resistance to a pulling force. So to create a resistance to a pulling force, that thing is used in weighing machine. It is initial tension that determines how tightly together an extension spring is coiled. So initial tension is there, already it is having some tension as compared to helical coil spring, so that determines how tightly together extension spring is coiled. Then this initial tension can be manipulated. You can also manipulate the tension, initial tension, to achieve the load requirement of particular application. So depending on your application, so if your weighing machine have a particular capacity of 30 kg, so you can adjust or you can say manipulate the initial tension. So this is the second one, that is extension spring, and it is also an extension of helical spring. Then third one is torsion bar spring. So you can observe the figure. So in figure or picture, it is a simple application of automobile. So in automobile, the at the chassis level, you can observe the torsion bar adjuster are provided here. The torsion bar adjuster are provided. So these things are used in automobile. The effect of torsion spring is based on how a steel bar react elastically to a twisting. So in that case, if you are moving in a particular weighing and it is having some kind of fluctuation, sideways fluctuation, so this sideways fluctuation can be controlled or you can say absorbed by the torsion spring. So there is some sideways movement when you move on a road, and if you are sitting in a automobile, so that four-wheeler have some sideways movement. So that sideways movement is controlled or you can say absorbed by the torsion bar. The torsion springs are just steel bars. These are the just steel bars, no helical is there, nothing is there, and it is basically reacted to a torsion. So some torsions twisting, that is the effect of the torsion bar spring. These are used in motor vehicle construction as an axle spring. You can clearly observe in picture also. In elastic shaft coupling, so in elastic shaft coupling also you are using the torsion bar spring. We will learn the coupling in next video. And in torque wrenches, so if you want to measure the torque value in case of wrenches, so you can use these kind of construction of torsion bar spring. Then next one is flat spring. So this type of flat spring you already use. So first figure in these are the some of the flat spring you are using in household application, so as to fit a particular pipe or you can say some wire, you can use these kind of arrangement. And in next you can see the these kind of things or you can say springs are used in tightening the sheet. You already use a drawing sheet, so for tightening the drawing sheet you can use this type of flat spring. So the simple flat spring consists of a strip metal of rectangular shape, square, triangular, or you can say trapezoidal forms. They are used as a sprace spring, contact spring, and for handle in safety clutches. So for safety purpose also, if you are using a clutches, so there you can use these kind of arrangement. They are also giving the support as well as safety also. So this is the fourth one, that is your flat spring. Now leaf spring. So these are used in many early applications. So in earlier cases, instead of other spring, you can also use the leaf spring also. Internal friction provides dampening. Due to internal frictions of the leaves, they are providing you the dampening effect. These are provide lateral location to the axle, and these type of springs are used in various automobiles, some of the heavy duty vehicles, in buses, car, or some ST. You are using these kind of leaf spring to a back wheel or you can say rear wheel, so as to absorb the shocks. Then next one is torsion spring. So you have already observed the extension spring. So they are having same construction but the purposes are different. you can see in picture also, in second pictures there are some windings are there, and these windings are get folded. So these kind of things use so as to lock something. So turning springs are mostly produced out of round spring steel bar like cylindrical coil spring, and are manufactured by winding around a construction bar. So on construction bar you are using these type of things. The end are bent depending on the use, so their ends will be bent according to their use. There are some application, if you are using a writing pad, so you can observe these type of things. If you are using a writing pad, some plastic pads are there, so you can see these type of things are they are using. And also some of the other applications are also there, where at the end some bendings are there, and due to that bending they are locked inside the portion. They are used in hinge spring, resetting the spring, and acceleration spring in precision engineering. So in precise application these things are used. We can observe the torsion spring in writing pad, and that writing pad having some metallic shape, so you can use these things, and these springs are get locked inside your pad. Then next one is rubber spring, or you can say shock absorber. These things are used in some heavy weak machine components, and so as to prevent the shocks. So these rubber springs are very useful. The rubber which is glued or vulcanized into metal piece or metal sleeves are stressed by thrust, pressure or rotation. So these things can be controlled with the help of rubber spring. Rubber springs are used for absorbing of oscillation or noise. So some machines are done some oscillation when they are get operated, or they are in operating condition, there are some vibrations, and due to that vibrations noise may create, some oscillations may create, so as to dampen the noise and vibration. So these springs are very useful, rubber springs. So these are the types of spring. Then next one is technical data sheets. Of course it is provided by Ajax Spring, and they are giving you the data sheets like part number, then their individual manufacturer's number, Ajax part number, manufacturer, they are giving the names, spring type, compression springs are there, material they are also giving you, music wire, a different materials is there, then wire size, then OD, so outer diameter, and some OAL, so lower diameter, they are also giving you the lower diameter of compression springs also. So these are the typical data sheets. So you already know the application of data sheets, why we are using the data sheets, because if you want to replace the spring, so these data sheets become very important. And if you observe in technical data sheets also, OD is very important here. OD become a very important, and also its part number. Then last one is, that is your troubleshooting. These are the stationary components, normally they are not moving, they can store the energy in the form of potential energy. So here is the kind of failure occur in spring. So the spring stress is the one of the important factor which is responsible for the failure of the spring. In most spring failure situation, the cause is the stress or force that exceeds what the spring is designed to handle. So if your spring is designed for a particular load, or you can say particular force, and you are still applying some more force on it or load on it, so obviously that stress may cause some damage to the its wire or coil, and that's why your spring will be permanently get into solid form, or it may some develop some cracks also, like that. So this is a one kind of failure. Then next one is wrong material choice. So if you are choosing the wrong material, and understanding the application of which the spring can be used is essential in the selection of its fabrication material. So on which part you are actually fitting the spring, so both the parts having must be having same material, otherwise what will happen, your spring will be get worn out as early as possible, or your spring must have some hard material as compared to the rod or whatever the application you are mounting the spring. So material choice is another kind of cause or factor which is responsible for spring failure. And last one is poor finish or incorrect finish selection. So if finishing is not proper, so they are prone to get some corrosion on it, and due to that corrosion it will be wear as early as possible. So this is the third one, that is poor finish. So these are the three factors of spring failure. Out of these three, first factor is more prominent, that is stress. If you are applying beyond its capacity, so obviously it will fail. So this is all about your spring. These are the three questions, try to solve. So thank you very much for your patience listening. In this particular topic we have covered the application of spring in mechatronic system, then spring fundamentals and types, and last one is troubleshooting. So thank you very much for your patience listening. Thank you.